Hello, so this is the polynomial series, and this is regarding the special cases of factoring polynomials. So the first one I wanted to talk about was the difference of two squares. So this is basically when two terms of the expression are both perfect squares and are being subtracted from one another. So the difference of two squares follows this general equation, which is a squared minus b squared equals the quantity a plus b multiplied by the quantity a minus b. So an example of this would be x squared minus 9. So as you see, just initially looking at it, you see that x squared is already in the a squared minus b squared form, but the number 9 minus 9 is not yet. So you would first find the square root of 9 to rewrite the terms in squared form, as I said in step 1. So you would say 3 squared, as the square root of 9 is 3, and 3 squared is 9. So yeah. And then, so you would substitute it into the right form of the equality, and you would get the quantity x plus 3 times the quantity x minus 3. So the second one I wanted to talk about was a perfect square trinomial. This is when the first and last terms of the expression are perfect squares, and the middle term is twice the product of the square roots and the first and last terms. So basically, you would use the given step here, and you would use the following equality, and that is a minus b squared equals a squared minus 2ab plus b squared. And so an example of this would be x minus 5 squared. So this is the second part of special cases when factoring polynomials. So the third one I wanted to talk about was the difference of cubes. So this is when a binomial has terms being perfect cubes being subtracted from one another. So the general formula for this would be a to the third minus b to the third is equal to a minus b times a squared plus ab plus b squared. So an example of this would be 8 to the third x to the third, minus 8. And as you can see, x to the third is already in the 8 to the third format, and negative 8 or minus 8 is not. So first you would think, what is the cube root of 8, which is 2. So then you would get your base 2, and you would just have to make it to the third in order to satisfy the rule, and in order to get 2 to the third, which is ultimately 8. So you would first get x to the third minus 2 to the third. So then you would substitute it into the pattern, and you would get the quantity x minus